Hello everyone. Today we will going to discuss previous year asked question in CSIR NET or GATE based on Massbauer spectroscopy. So let's start. The correct order of the isomeric shift in Massbauer spectroscopy in iron 57 source of iron compound is A option, this one, this or this. What is the order of the isomeric shift? So firstly we will discuss what is isomeric shift. Isomeric shift is just the shifting of nuclear energy levels of the source and absorber due to electrostatic interaction between the nuclei and the electron. Okay. Isomeric shifts depend on radius of nuclei in ground state and in excited state, and also depend on the electron density at the absorber nuclei and electron density at the source nuclei. So since s electrons have a finite wave function at the nuclei and p and d orbital have vanishing wave function at the nucleus, so it is only s electrons which are responsible for the isomeric shift. See, Fe plus 2 oxidation state, F in plus 3 oxidation state, and in plus 4 oxidation state, S electrons density. In all three states, S electron density is 0, but D electron density vary. Isomer shift directly depend on the D electron density and inversely depend on the S electron density. There D electrons are more, so isomeric shift in plus 2 oxidation state is more than isomeric shift in plus 3 oxidation state than plus 4 oxidation state. So our correct option is this one. Okay. The next question is, in Massbauer experiment, a source emitting at 14.5 kilo electron volt had to be moved towards absorber at 2.2 mm per second for resonance. The shift in the frequency between source and absorber is, the given options are 15 megahertz, 20 megahertz, 25.5 megahertz and 30 megahertz. So what we will calculate? We will calculate the shift in the frequency between source and absorber. So we calculate frequency shift between source and absorber by Doppler shift. So by Doppler shift, del mu is equals to mu into V by C. This is the frequency, V is the velocity of absorber and C is the velocity of light. So by this formula, we will calculate the frequency shift and we get 25 megahertz. So our correct option is 20, because 25 is approximately equals to this option 25.5 megahertz. So correct option is C. Next question. Among the following, those act as Massbauer nuclei are iodine 129, cobalt 57, iron 57, antimony 121. These three nuclei are Massbauer nuclei, but cobalt 57 is act as a source of Massbauer spectroscopy, not as a Massbauer nuclei. So correct option is answer D, 1, 3, 4 only. Okay. Next question. To record Massbauer spectrum of iron containing sample X is used. X after nuclear transformation Y gives gamma radiation used in Massbauer spectroscopy. Then X and Y respectively are. Given options are iron 57 beta emission, cobalt 57 beta emission, cobalt 57 electron capture, iron 57 electron capture. So as we know, cobalt 57 is a radioactive element and it captures electron from K shell and decay into iron isotope. Okay, so cobalt 57 capture electron from K shell and decay into iron 57, which is in excited state, and this excited iron atom split into its ground state and emit gamma radiations. So our correct option is cobalt 57 act as a source and it capture electron. Okay. Next question is, if Mossbauer spectrum of FeCO5 is recorded in presence of a magnetic field, the original spectrum with 2 lines changes into. Options given are 3 lines, 4 lines, 5 lines, 6 lines. In FeCO5 molecule, 2 lines we observe due to these 2 type of carbonyl groups. 2 are axial and 3 are equatorial. But when we observe the spectrum in presence of magnetic field, these 2 signals split into 6 signals due to coupling. These 2 signals split into 6 signals. It gives 6 signals. So correct option is answer D. Next question is, Mossbauer spectrum of a metal complex FeCN5NO is doublet because of the presence of weak sigma bonding, extensive pi bonding, extensive sigma bonding and weak pi bonding. As we see, this nitrosyl group NO ligand show back bonding with metal ion. Due to these 2 pi bonds, extensive pi bonding, we will get doublet. So correct option is extensive pi bonding, D option. Next question, which among the following does not show quadruple splitting in Mossbauer spectroscopy? So observe these 4 molecules. Firstly, we will discuss quadruple splitting. Why quadruple splitting occur? Quadruple splitting obtained due to 2 reasons. Due to asymmetrical ligand environment and due to asymmetrical and electronic environment. Inhomogeneous field with an electric field gradient, that is asymmetry in ligand field, or asymmetric electronic charge distribution generate electric field gradient. These 2 reasons are the main reasons of quadruple splitting. Now see the 4 options. In first option and in fourth option, ligand asymmetry is present. 2 type of ligands coordinated with iron atom, and there also 2 type of ligands coordinated with iron atom. So these 2 are eliminated. Now see the option C and B. In this one and this, FeCN6 plus 4 plus 2 oxidation state we will get for iron atom. So in plus 2 oxidation state, iron 6 electrons are present in d orbital. So these, if there is a Cn negative ligand, Cn is a strong field ligand. Due to this strong field ligand, these electrons are pair up and give the symmetrical electronic arrangement. But in FeCN6 3 positive, this complex, iron present in plus 3 oxidation state, and in this 7 electrons are present in d orbital. So asymmetrical electronic arrangement is present. So our correct option is option C. Next question. Mossbauer spectrum of a metal complex gives information about oxidation state and spin state of metal, type of ligands coordinated to metal, nuclear spin state of metal, geometry of metal. Mossbauer spectrum give information about oxidation state and spin state, type of ligand coordinated to metal also, because by the structure of molecule or by the Mossbauer spectrum of molecule, we will get the information about the ligands, how many type of ligands are coordinated with it, and also we will find out geometry of the metal. But Mossbauer spectrum does not give any information about the nuclear spin state of the metal. So our correct option is A, B and D. First, second and fourth. So correct option is C. Last question but not least. In the Mossbauer spectrum of this one, a single peak is obtained which reveals that iron in the complex exists as spin-free iron in +3 oxidation state, spin-paired in +3 oxidation state, spin-free iron in +2 oxidation state, spin-paired in +2 oxidation state. Firstly, we will calculate the oxidation state of iron. As in this complex FeCN6 4 negative, due to this 4 potassium ion, this one we will calculate the oxidation state of iron. Now we will get what we get, +2 oxidation state, iron present in +2 oxidation state. Now calculate the spin free iron and spin paired. In +2 oxidation state of iron, 6 electrons are present in d orbital, and due to strong field ligand, as Cn is a strong field ligand, these 6 electrons are pairing occur. So spin paired and +2 oxidation state. Our fourth option is the correct option. Thank you.